So to count a range, we need first to know what is a range. There's a built-in function called range that constructs a range object. It's actually a constructor with a range object. Range object is called a generator object. We might study that in Python 2 later. But generally speaking, the generator is an object that an object generates a sequence of integers. Okay, and the generator function or generator object don't hold the entire data it will generate. Imagine if I want to count from 0 to 100 million, do I need to keep all of these numbers in the memory? Of course not. It would be too much. What happens actually is that they keep only the parameters and the current status to generate the items one by one in the runtime when they are asked to do. Okay, this is more efficient than generating the list and iterating over it. It's called generator functions. And because the generator functions don't and on objects don't hold the whole data in memory, you cannot extract all sequences or all the range at once. So if you want to generate all the extract the data, all of it at once, you have one of two options. You can either iterate on them one by one in a loop, like I in range of I whatever, or wrap the whole object in the whole sequence, the whole generator in an iterable sequence, and they should extract them for you, and then take the iterable and work on it. The most famous form for this is to use the range in the list constructor in this format. List of these parentheses are called of, and the range object. So this is how range object works. Now let's see what range function does actually. Range is documented in the Python documentation. I give here the library documentation of standard types here. So this is ranges. This is the whole documentation in the standard in the library. We have start, stop, and step. Nice things to read. Really nice things to read. Okay, I will need you to get used to reading the documentation over the coming days, coming weeks. So here, what I care about here is that this is the header. Screenshot of the header here. Class range, which takes one parameter called stop, and another constructor class range which takes three parameters: start, stop, and step. And here step has a default value of 1. If some function has a parameter with default value, then it's optional. You can give it a value or just ignore it, and the default value will be used. That means we can call the function with one parameter, or the function with the three parameters with the step or without step. So we have three options here. Range of stop, first case. Range of start and stop, second case. And range of start to stop and the step, giving a value for a step, which is the third case. If you are calling the first case, first format, stop, so that the default start will be 0. It will start counting or giving a sequence from 0 to step exclusive. That's step -1. I think we heard this before. This is déjà entendu. deja vu. Zero to stop exclusive. We hear that before. Where? Yes, in slicing sequence, right? Yeah, that's right. Okay, so I keep it in my mind. The second format, start and stop, generate a sequence from start, stop exclusive. Yeah, that's very similar to what we heard in slicing, and also it has the default step of one. The third format, similar to the second format, but just you give step a value. Now if you have not uh, studied the slicing process, stop this video, go see the slicing video, and come back. Let's try some examples of slicing. Oh, sorry, of range generation. If we print a list of range of 5, giving it only the stop is comparable to list of empty and the stop. Remember empty? I hope you remember that. This will generate a list of the range from 0 to 4. Let's try that before we go any further. Range examples. I try only the first example now. So print list of range that stop at 5. Range will generate the sequence. List will take the sequence and convert a list, and the print will print the list. Yes, from 0 to 4 within square brackets. That's a list. Okay, that's nice. We are the right bus. Second option is second example is range of 0. Compare this to a list of 0, list of empty and 0. Empty starts with 0, and here the end exclusive is 0. That will leave nothing because 0 is both the start and the excluded end. So end up with an empty list. Range of 0 and 5 is very comparable to is producers should produce the same value because already 0 is the default value for the start. So these two should be identical. Okay. And the last one in this slide is range from 1 to 5. This will exclude 0. We start from 1 up to 5 excluded, exclusive, which means up to 4, as what we used to write to find when we wrote list of 1 to 5. So 1 is inclusive, 5 is exclusive. This will generate 1, 2, 3, 4, 5. Let's see them all. The rest of them. Run. Okay. The first one reduced from 1 to 4, from 0 to 4, sorry. The second one, range of 0, is empty. The third one is equal to the first one because this is already 0. And fourth one starts from 1 to 5 is close to 1, 2, 3, 4 only without 0. Okay. Before we go further, I want to show you something that would be nice. Print, let's say, RR equals range of 5. Print type of RR. Let's call it R1. Means range 1. Okay. We also want to do similar thing. Now R2 equal range of 0, 5, and print R2. Let's print that. Class range. Okay. Instead of printing the type only, print the type and the representation. Now you've seen this rep already. R1 and rep of R2. Okay. Run. Class range represented as a range of 0, 5, range 0, 5. So that means these two, range which takes one parameter and range which takes two parameters, the first is 0, are identical. Okay. Next slide. Now let's add the step parameter. You know that the default step is 1. So let's add something different. Range from 0 to 101, step 20. Step 20 adds 20 to 0 will be 20. This will be 0, 20, 40, 60, 80, 100. Note here that the end is 101. It's comparable to list. When you have a list and you slice it from the first element to element number 101, step 20. List of range of 100 to 1000 with step 100. This will produce 100, 200, 300, 400, 500, 6, 7, 8, 900, but not 1000. Why? Because 1000 itself is exclusive. So we'll build from 100 to 900. Can we start from minus numbers? Yes, of course. It can take negative or positive numbers. So starting from minus 10 with step of 4, minus 10, minus 6, minus 2, minus 2 plus 4, minus 4 is 2, 6, no 10. Why? Now you know. Okay. Let's do the same thing with, but from up down. So instead of step 4 to be step minus 4, starting from 10 to minus 10, we'll give 10, 6, 2, minus 2, minus 6, and there is no minus 10 for the same reason. You know it. Okay. Zero, 20, 40, 60, 80, 100, because we end at 101. The rest of them don't show the last element, whether it's 1000 or 10 or minus 10. 900, 6 but not 10, minus 6 but not minus 10. Okay. Now we know what range does, how it produces the sequences. Let's iterate over them. So range function can be used as the loop iterable because it generates a loop, constructs a loop generator. Sorry, a generator object. By convention, when we take an index from a range, or an enumerate. We'll see enumerate at the end of the slide. The indices are called I, J, K, and L by default, by convention. Okay, you can name them anything, but usually by convention, so that when I see I in the in a code, I know, oh, okay, this is a counter. It doesn't have a specialized meaning, uh, like X, Y, grade or score or average or whatever. So for I in range of 5, it will take values sequentially from 0, 1, 2, 3, 4 only. Print uh, I equals, and print I itself, I squared equals, and print I to the power 2. What will be the output here? This will be the loop body. It will iterate to right I equals 0, squared, I squared 0, I equal 1, I squared 1, I equal 2, I squared 4, 3 squared 9, 4 squared 16. The body is executed every step of the loop with the value updated to the one value of the range from 0 to 4. Similarly, for I in range 0 to 10 to 101, said earlier, print that. Let's see them. In 20, 30, 45, 50. Oh, this is, I've seen this already. 20, 20, 30 up to 100. Okay. Let's count down before the boom. For I in range 10 to -1. Now we know -1 is the value next to 0. Step -1. We will count down. Let's print countdown before the loop. And in the loop body only print the counter decrementing. And when we reach 0, will be the time for boom. Maybe open. This will make our life easier. Yes. Counting down. 10, 9, 8, 7, 6, 4, 6, 5, 4, 3, 2, 1. Boom. Okay. So we use the range as just a sequence generator that generates the numbers as we give it to it. And it's very lenient and very nice. So, handful tool to get what we need. One question for you. What will happen if we indent print boom? Let me give you a hint. If I indent it, it means it will be with the same indentation level of the print of I, and it will be part of the loop, and then you can expect what will happen. I will not try that. You try it yourself if you want. Okay. Next is using range as a counter. Sometimes you just need a counter. No, don't need exact. Don't need to use the values. So if you don't care about using the iteration variable in the body, so just name it underscore. This is the convention. So if you will use it as a counter, you can name it I, J, K, and L. You don't need it, just name it underscore. And by the way, in some IDEs, like by Churn, if you are using the personal version, it will give you a warning. Unused variable called the I here. Change it. So nice to change it. Okay. Naming the variables that were not used as underscore has two benefits. It preserves the I, J, K, and L for other uses, and it prevents naming collisions. Because maybe there will be another I or another J or another something later. Sorry, earlier or later. So this will prevent name collision, knowing that okay, this is unused variable, just used as a counter. Besides that, for underscore in range 10, print life is fine. I don't use the counter inside the loop. I just want to print life is fine 10 times. I don't use it. I don't need it. So I named it here underscore. That yes. Life is fine generated 1, 2, 3, 4, 5, 10 times. Finally, about this point here, we want to say that range can be used to generate indexes. It can be itself. It's an integer number, so it can be used itself, or it can be used as an index to select from sequence. So we have values 2, 10, 15, whatever. And for I in range of len of values. Now we have some values, we don't know whatever it is, arbitrary number. And length is the built-in function which will use the length of the sequence. Okay. We feed the length of the values to range, so it will generate numbers from 0 to -1. This is exactly what is needed for indexing. So I can print value number I equals values of I. So here I got the values not by iterating over the values itself, by iterating over the range again, not for value in range, but for I in on range. Sorry, not for I in values, but for I in range of len of values, and then I get values of I. That's why I put it in bold here. See it. Okay. Next topic is nesting for loops. This is a very, 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 very nice topic. Maybe I put it in another video.